radio for the masses.
Headline edition, July 8, 1947. The Army Air Forces has announced that a flying disc has been found and is now in the possession of the Army.
If the game is rigged, change the game. Game changer.
I occasionally think how quickly our differences worldwide would vanish if we were facing an alien threat from outside this world.
This is Fade to Black with your host, Jimmy Church, on the Game Changer Radio Network.
All right. Good evening. How you doing? It's Tuesday, October 14th, 2025. Let's do this, man. I am your host, Jimmy Church. All right. We've got a great show tonight. Another great week here on Fade to Black. Just let me get this stuff out of the way really quick. I've got last night, Rick Osmond was here, the history of lost America. Tonight, Lawrence M Krauss joins us, 3-Eye Atlas. We're going to do some cosmology and some other stuff. I promise Lawrence will keep the woo out of the show tonight as much as we can. Tomorrow night, Lynn Buchanan is with us, an original gangsta OG remote viewer for the military and Project Stargate. That's a really big deal tomorrow night. Lynn Buchanan is here. And then Thursday night, we have screenwriter and director M.D. Selig is here. He's got a great series out on Netflix. And we're going to be talking about how he creates science fiction based on fact and his version of facts and why he may be a whistleblower because of the way he does his stuff. And that is Thursday night. Great week here on the show. I do have 7 events coming up. 2026 is upon us. I've got the Conscious Life Expo, the largest conference in the world, February 20th through the 23rd at the LAX Hilton, 25,000 people. I have been the host of this event for the last 12 years. So we'll see you there. Sedona Ascension Retreat, March 20th through the 22nd in Sedona, Arizona. The Contact Modalities Expo, May 1st through the 3rd, 2026 in Delavan, Wisconsin at the Delavan Lake Resort. I'm back out here for Contact in the Desert, May 28th through June 1st. Tickets on sale this Thanksgiving Day. Then I head south to Peru for the Inca Celebration of the Sun with Brian Forrester. That is June 23rd through July 1st. After that, I head over to Scotland for the Monty Python Tour of Scotland. And that is August 1st through the 9th, 2026. Hosting this is going to be really, really cool. And we've got some amazing surprises that are going to happen. Use your imagination. I come back from that and I head back south to Peru and Easter Island. And that is in November of 2026. All right, kids. Let's get started. Tonight, Lawrence Krauss is with us. We're going to be talking about 3-Eye Atlas, which is upon us, and some other stuff. I want to get into physics and cosmology and his work and history, and I'll try to get everything out of his head and into mine so I can get my edumacation on tonight. Yes, not only the insights of 3-Eye Atlas, but and the possibility and some of the claims out there and how we look at that. There is a lot of attention, focus, sensor data, telescopes, everything is focused on this object right now. What is it? What is it? Well, tonight we're going to try to peel back that onion layer. Professor Lawrence M Krauss, theoretical physicist. We know that. Cosmologist. We know that too. Also, best-selling author, known for his groundbreaking work on the intersection of science, philosophy, and public understanding. He's a former professor at Yale, Case Western Reserve, and Arizona State University. And his books, which I have read. Now, we talk about dark energy, dark matter, and all of that stuff for the universe every night on this show. But it's his books that have changed me. The Physics of Star Trek, I've got it. The Universe from Nothing. I have read that book so many times. We're going to talk about that tonight, too, as well. He's the president of the Origins Project Foundation and continues to bring together leading thinkers to explore the deepest questions about the universe and humanity's place within it. And I would like to welcome for the first time to Fade to Black, he's right there, Lawrence M Krauss. Lawrence, how you doing tonight, young man?
Oh, I feel very good to know my books have actually affected you. That makes me feel even better. I'm glad I agreed to do this. So that's great. I'm doing fine.
You
In my
know,
new house that as you can see has not yet been moved into. Anyway,
it'll be professorly soon.
yes.
Yeah, I feel comfortable in saying that. I want to start with a couple of things. Actually, hold on. You get the first time guest disclaimer. So we've got to get that out of the way. It's a tradition. And it goes like this, Lawrence. It's just you and I sitting on my couch having a conversation as friends. And where the conversation starts, it starts. Where it ends. But we're going to end as friends. But you have to accept so we can move on.
Well, that's what I was planning anyway. So I'm okay.
Fair enough. I actually want to start here before we get into some knowledge stuff tonight. There is, and you're going to enjoy this question. I would say that there is a general public perception and maybe criticism of science and physics over the last 300 years about the lack of open minds, and that we've moved into just staying on the highway and not driving off of it and getting outside of the box. Is that criticism accurate?
No. One of my favorite mantras comes from the former publisher of the New York Times, who liked to say, I like to keep an open mind, but not so open that my brains fall out. And that's always been my motto. But the point is, look at the change in science over the last 300 years, the development of relativity, quantum mechanics, the discovery that empty space it has the dominant energy in the universe. These are things that are beyond crazy. Yet we've realized the universe works that way. I don't see how you could be more open-minded than to realize that the universe operates by the laws of quantum mechanics, which are truly on the normal everyday level insane. And as I say, when we discover something we don't like, and I must say that the fact that empty space has energy is something that
right.
I proposed it. I hated the idea, but it looked like it was true, and it is true. And so we've come to accept it, and whether we like it or not. And at the same time, if we're wedded to an incredibly beautiful idea that we just love, and it's central to our being, if tomorrow an experiment shows that it's wrong, we throw it out like yesterday's newspaper. So I don't know. That's the great thing about science, is that we learn to throw out cherished ideas and to accept things that we may not like if the universe operates that way. So I think that's the prescription for discovery. And I don't see how you can get more open-minded than that.
It sounds like you've never been asked that question before.
Well, not in that way. I have to say, not in that way. I think
you certainly understand it, though, and the public doesn't understand necessarily, but there's a frustration there, and we hear it over and over again. I ask every physicist and scientist that I have on the show the same question. And I think that generally they will force this into, well, it's a funding environment. You know, we can't get into the woo. We can't go into consciousness. We can't do these things because we're in an environment and in a career path that we just need to stay focused. And it's a political answer, but I understand that answer too.
Well, look, I don't even buy that. I think scientists, we're funded by most scientists are funded by the government, and but most scientists do what they're interested in. I mean, I always like to say that sort of a grant proposal is an exercise in creative lying, in a way.
Right.
Well, because at least in my case, and some people don't do science like I do, and it takes all types. But in a grant proposal, you explain what you're going to be doing for the next 3 years or 5 years, depending on the length of the grant. But I always feel like if I know now what I'd be working on in 3 years, then it's just no fun, because there are going to be discoveries between now and then, and I'll change what I'm working on. And so I think that we couch what we're interested in language that works within the context of a grant, parameters of a grant, and then we do what we want. So
It's about the most honest answer. It's about the most honest answer I've ever heard.
Oh, good.
No, it's spot on.
Okay. Well, no, I try to Call them as I see them.
Now, tonight we're going to be talking about 3I Atlas, and to lay a foundation for that discussion, as we all know, 1995, 1994, 1995, when the first exoplanet was verified, and where we are today, our knowledge of the universe is increasing exponentially. Like, it's just crazy what we know today. And what we didn't know then, 30 years ago, it's crazy that we still didn't know if we were all that there was as far as the star system goes. And now with confidence, we can generally say that every star in the universe has probably got a planet. And now we're getting into a numbers game that is very hard to wrap our head around. Is that an indication to you that the amount of life out there, not quite infinite, but it's a pretty big number, isn't it?
Well, look, let me say, I was going to say, as an astrophysicist, and I do that among other kinds of physics, we kind of knew, we expected 30 years ago that every star would have planets around it, because when you built star systems on computers, you saw these accretion disks form that would fragment. And so it was I would say, an expectation that it could be likely that there are 100 billion, well, we know there are 100 billion or so stars in our galaxy, that there could be 100 billion solar systems. The huge surprise, which wasn't expected, was that the kind of planets that could form around stars were totally different than we had expected. We thought, okay, well, it's reasonable to assume that our solar system is typical. So there'll be, a bunch of planets. There'll be rocky, smaller planets on the inside and gas giants on the outside, like there are. And what we discovered is that basically it's far more interesting than that. That almost anything you can imagine exists. There are systems with gas giants that are close to stars, and all of these things that we thought were probably not possible to form. We didn't think they were impossible. It's not that the fundamental sciences rolled out, but we were creative enough. The imagination in nature always exceeds our own, and so we discovered that that we're not at all typical necessarily. And now there's a selection effect, because we can only look at certain stars and look for planets. So it's there's this old line about if the drunk leaves the bar and loses the keys, where do they look for them? They look for them under the lamppost. Not because they're there, but it's the only place they'll find them, because they can see it, right? And that's right. What we do in physics. We look where we can look. So if you're looking for planets, you have to see a star, and one of the ways we find them is if the planet goes in front of the star, it dims it a little bit. So, and then it has to be close enough so that it goes around enough times so that in a year or two or three or whatever observation, you can see that happening. And so that produces what we call a selection effect in physics. So we're not looking at all planets. We're looking at the ones we can see. But even so, we've discovered just remarkable things that we wouldn't have thought were possible. But it has confirmed that indeed almost all stars have planets around them. But having said that, there's no evidence yet that any other planet is even habitable. You'll read about that in the newspaper, and then you should always read, like everything in the newspaper, you should read with a grain of salt. Especially in the case of astrobiology, I'm afraid to say, which is a new area of astronomy, which is almost a science, and maybe one day it'll become one, in my opinion. There's a lot of hype, and you hear about all these new discoveries of potential life here or there, and the problem is we don't even know how life formed on Earth, right? I mean, we have good ideas, but no direct way to know that. And so anything we speculate about other planets and the origins of life on those planets is pure speculation. Now, when you read in the newspaper that a habitable planet has been discovered, all it means is that you can tell how far away it is from its star, and how hot the star is, and how likely it is, therefore, that the surface temperature on that planet is such that liquid water could exist. That doesn't imply that liquid water exists. And
you know what's the most fascinating part about that statement, though?
What?
Is that we can now actually have this discussion based on data.
Exactly. And we have a lot of data of a lot of stars. There's over, I don't know what, every year it's different, but there are probably over 4,000 extrasolar planets that have been discovered. And some of them are in this Goldilocks zone, which is where liquid water could exist. Now, by the way, we don't know. We know of one example of life, and that's on Earth. And then we're trying to extrapolate to the universe. So what we do first is look for life like Earth. And liquid water on Earth, we think, was pretty essential for the evolution of life here. Is it always essential for the evolution of life? We don't know. But the first thing to do is look for that. And if you don't find any life on those kind of planets, maybe then you'll broaden your search to other more exotic kinds of life.
Let me ask you this. I just interrupted you, Lawrence, and I apologize for that.
I interrupt other people, so I'm very interested in.
You know what? You've got a poker chip. You can use it on me next. Is this? And then we'll get to 3i Atlas.
No worries.
The scoop that we got from asteroid Bennu, which, as you know, crashed in the deserts up in Utah, and we retrieved it. And what we found in one scoop off of a random asteroid, we've got 20 amino acids that make up RNA, and the five proteins that make up DNA in one scoop of a random asteroid. That says a lot of things to me. What has been, again, a big surprise over the last 40 years is, even before we scooped that little bit, and you got it right on, is that we were actually able to look at comets and asteroids and look at the spectrum of light emitted by those things. And that spectrum tells us what materials are there. The same way a spectrometer on Earth is used to determine what the makeup of chicken soup. But and we've discovered, and what was really a big surprise was that complex organic materials, complex, even complex hydrocarbons existed on those objects, which was a surprise to some extent that those things could exist. And now, as you say, we discovered that amino acids and potentially ribonucleides, the basis of DNA, are synthesized on those objects. And there's a lot of energy, there's a lot of light, and chemistry can happen. And so it does lead to the possibility, not quite panspermia, which was suggested by Francis Crick a long time ago, who suggested that life, one of the things that's amazing is life evolved on Earth about as soon as the laws of physics would have allowed it to. Within a few 100 million years of the evolution of the Earth, life was here, and it probably couldn't have existed earlier because of the heavy bombardment of asteroids and comets before Jupiter either kicked them out of the solar system or ate them. And so life formed really quickly, and that could be due to one of two things. Could be that it's easy for life to form, or it could be that maybe life was seeded, and he suggested it was DNA from other civilizations or something else. This isn't that. This is saying that in interstellar space, there's biochemistry, there's chemistry happening, and it forms the basis of the kind of materials that make up the DNA, which is essential for the replication of life here on Earth, and RNA as well. And so that is very exciting, because it does increase the likelihood that life may exist elsewhere. It suggests perhaps that if those building blocks if you didn't have to wait to get to the Earth to build up those things, then you jumpstart, you're one step ahead. It's still hard from there to make life, but not impossible. And so you're absolutely right. It's an amazingly important discovery. It makes us more optimistic that there's life elsewhere in the universe. And by life, I mean microbial life, not necessarily intelligent life. But I do want to point out that there's no evidence in most of the so-called habitable planets that people have looked for. It's not even clear there are atmospheres, much less organic materials. And so you'll hear about these things, and maybe this is a clue, and maybe that's a clue, and maybe on Mars there's evidence. It'd be wonderful, but we have no evidence of it so far, and it's still possible, although I would bet against it, that we are alone in the universe. Now, by alone, I mean as a life form. I don't know about intelligent life. I'm betting that in our solar system, there will be discovered other
examples of life originating, probably not on Mars,
Europa.
but in the oceans of Europa or Enceladus, underneath the ice. And those are more interesting because why are they more interesting than Mars? They're more interesting because Mars, if you're old enough, and you are, and I am, to remember, I think it was 1996. I think it was when Clinton was president, and you remember he held a press conference in the White House saying we've discovered evidence that there's life on Mars, that there was extinct life on Mars. A Mars meteorite from Mars, which was discovered in the Allen Hills in Antarctica, had been carefully examined by some chemists at Stanford, and there are these little nodules that look a lot like the oldest fossils of life on Earth in Australia, 4 billion-year-old fossil. Turns out they're 50 times smaller, and it turns out there's other ways to make them than organic materials, and so now that's kind of that supposition has been largely discredited. But what it did point out is that no planet is an island. That Mars meteorite was not discovered on Mars; it was discovered in Antarctica, and that means that materials from Mars is regularly ejected and makes its way to Earth. And we now understand that extremophiles can live within rocks for a long time. And so, the interesting possibility is, and my friend Andy Knoll, who works on these things and is an expert on early life, he's at Harvard, has said if we find evidence for extinct life on Mars, the biggest surprise would be that it isn't our cousins, because Mars has polluted us, and a lesser probability we polluted Mars. So if you want to see what a Martian looks like, you may want to just look in the mirror, because it's quite possible that in the early history of our solar system, when Mars was hotter and wetter, that the first forms of life could have evolved on Mars and then polluted the Earth. So if we discover life on Mars, it would be surprising in some sense if it were different. Now, how do we know it would be different? Well, if it didn't contain the four nuclei that for in DNA, the ones we use, and all of that. And I suspect it would if it were discovered. Now, the more interesting thing about Enceladus or Europa is that there are vast oceans underneath this thick layer of ice. So those oceans have been separated from the environment of the solar system. And if we were to drill down, and there are missions suggested to do just that over the course of the next decade or two, and if we were to discover organic, evidence for microbes, that would be much more definitive evidence of a second genesis of life in our solar system. And if life arose separately twice in our solar system, then that would basically tell us that the galaxy is just teeming with life.
Yeah, it's full of it. Well, that's where octopus come from. They come from Enceladus.
It could be. There's certainly otherworldly. I think, is it octopus or octopi? Anyway.
Well, I'm only talking about one, so it's octopus.
Okay. Yeah. One octopus. So anyway, I have bets with people about this. I think it's likely. If you were to ask me, I wouldn't be surprised if there's life in the oceans of Europa or Enceladus. But by the way, I also have a bet with my friend Richard Dawkins, a famous biologist who's also a friend of mine. The institute I ran at ASU ran a bunch of scientific meetings, and one was on the origin of life. And I became convinced, listening to the chemists there, that I suspect life is governed by chemistry and physics. And basically, chemistry found what I think may be the unique road to a self-replicating system with metabolism. And so I think that the nature of DNA as we now know it, and ATP as a molecule that is the store of energy and energy transfer in biological systems, I wouldn't be surprised if that's almost unique. If it was kind of the best that life, and by not intelligently searching, but just by random processes, seeking out all the different mechanisms to exist, found the best mechanism. And if that's really true, I've got to bet that if we find life on Europa, which is a second genesis, I wouldn't be surprised if it had the same 4 base pairs and ATP and all the rest.
For sure.
And I'd love to be proven wrong.
No,
But
you won't be. Let me tell you why. Let me tell you why you're spot on. By the way, I ride a Harley. I don't have a PhD, but I got a pretty good grip on this stuff.
yeah,
And
that's
it's
fair.
this.
Mhm.
There are only so many particles. Period. There's not infinite particles. They only combine so many different ways. It's finite. That's it. It's the same on the other side of the universe as it is here. And
Uh-huh.
Bennu certainly showed us just that these particles can combine in certain ways to allow the possibility of the creation of life. And
Well,
if it happens,
that's just because chemistry is governed by physics, and the laws of physics are universal everywhere. And you
that's
have
right. That's
and
right.
matter is made of protons, neutrons, and electrons, and you put those two things together, and only certain configurations can exist.
That's
Yeah.
it. That's it. And so it's a numbers game. And so I'm betting on the Vegas side of this, where there's so much out there, the universe is so big
Yeah.
that we are now, especially with the James Webb, where we've achieved this point of the ability to understand and know things, that we
Yeah.
can now peer into the atmospheres of exoplanets. Well, if there's life out there, they are doing the exact same thing that we are. They're looking, right? So why? And we're this beautiful blue gem. We glow. We have lights and we have stuff here, and we're pretty easy to spot. And we're out there looking for it, and they would be too. And so I think that there's advanced life out there, whether they've been here or not. I don't know. But I would say that they're certainly aware of us. And as a betting man, I think that's the safe bet.
Well, I'm not so certain. I wrote about it in the Physics of Star Trek, actually, because
Great book, by the way. Great
thank you.
book.
Here's the analogy I gave then, and when cable TV started, I'm old enough to remember there were like 6 stations when I was growing up, maybe 4, because I was in Canada. And that was easy. And then cable came on. There's suddenly 200 stations, and by the time I found the program I was looking for, it was over. And in the real universe, there are an infinite number of frequencies to listen to, and so you can have some ideas where you might broadcast at what frequencies, but even if you knew exactly, even if you were in an alien civilization, an alien planet, and someone told you exactly where to look at, say, look at that star there and look at the third rock from that sun, there'll be life on there. Well, even then, it'd be extremely hard to find life because, first of all, we've only been, let's say they're advanced civilization, and we took 4.5 billion years to evolve here, but let's say most civilizations, our sun, the solar system, the galaxy is 12 billion years old. We're only 4.5 billion years old. So let's say these advanced forms of life have been around for billions of years, longer than us. Okay, let's just say. So they could be looking at the Earth for billions of years, and only during the last 100 years or so would they find evidence of intelligence, because we've been emitting I Love Lucy and all of that stuff. So if you work it out, that's like a 1 in 50 million chance of finding life on Earth, even if they were told where to look, and that's if you knew what frequency to listen to. But we don't even know that. So
and you would have to be 100 light years away to even see I Love Lucy.
Exactly. If you're 1,000 light years away, too bad. You don't see any evidence. Well, I mean, you might see green. You might look at the Earth and say there's life there, but no evidence of intelligent life. And so it's a lot harder than you might think. And so my suspicion, I'm pretty well convinced that the universe is teeming with life. And I'm also reasonably convinced that there's intelligent life elsewhere in the universe. But I also think it's a reasonable likelihood that we'll never know about it. And the other possibility, of course, which I think is maybe even more likely now, especially looking at our society right now, is that intelligent life doesn't exist for very long.
That's the question I would ask E.T.
Yeah,
I swear, Lawrence, on all that I love, I'm my daughter. You know what comes out of my mouth? How did you guys do it? How did you survive?
Yeah, yeah.
That's it. How did you guys do it? Because we need that advice. That would be my question. How did you do it?
Yeah, no, well, that would be a great question to ask. I agree, because it would be really surprising. And that's, by the way, why I like Star Trek, because most science fiction is kind of dystopic. It presents a future that's awful, and science has made the world worse. And what's great about Star Trek is it presents a universe that more or less, at least for the Federation, where science has made everything better. It's gotten rid of notions like God and even money, I suppose, and somehow made for better life for everyone. And that's a lovely idea. I'm not sure how realistic it is, but it's a lovely idea. And science could do that, right? Because science brings people together in ways that politics doesn't. You look at the Large Hadron Collider, and you have 10,000 physicists from 100 different countries speaking dozens of different languages, all working together effectively towards a common goal. I don't think anything unifies humanity better than science, because where there's common goals that are independent of sort of culture or language, sex or gender, and all the rest. So science should and could make the world a better place, and I think it has, by the way, in large. I think science and the Enlightenment have made the world a better place. And what saddens me, and my last book is about that, is that there's this anti-Enlightenment effort to somehow argue that objective knowledge doesn't exist and all the rest, and it's a result of white supremacy or Western whatever. And I think that's so sad, because science isn't Western. I mean, it was dominated since the Enlightenment by the West, but certainly has its origins in other places, and great mathematicians and great scientists around the world. And I think it's I think the Enlightenment has helped, and in fact, there's a great example that historians given, that Newton's discovery of the universal law of gravity was responsible for the ending of the burning of witches.
Yeah, I've heard that too. Yeah,
because the idea is, look, if it used to be that they thought the planets went around at this time. First time they all thought they all went around the Earth, but then the sun was discovered. But angels pushed them around and all the rest. And then Newton discovered you don't need angels, you don't need any of that. Everything, even the motion of the planets, could be predicted by simple laws. And if that was the case, then then physical effects have physical causes. And if physical effects have physical causes, you probably can't blame a thunderstorm or a bad year of drought on the witch down the road. And so I don't know if this is speculation is true, but anyway.
Oh, well played, Lawrence. Well played. Well, it seems that, okay, steering this right into 3I Atlas, what if it turns out to be artificial or there's something else beyond something natural? And this is a multi-layered question tied into that. What if you saw a flying saucer one night? Do you apply that to your knowledge base? Do you apply that to 3I Atlas? Does it change? Is there a paradigm shift for you? Or do you search for another explanation for what you saw instead of it being something extraordinary?
Extraordinary claims require extraordinary evidence. Okay. That's Carl.
Do your eyeballs apply to that is what I'm saying.
No, my eyeballs are fooled all the time. Right. And
right,
so
right.
As Richard Feynman once said, it's far more likely to attribute UFOs to the known irrationality of humans rather than the unknown rationality of aliens. Okay, in the physics Star Trek, but the book I wrote after that called Beyond Star Trek, I tried to argue pretty clearly that almost any possible explanation of what you might see that you think is UFO, almost no matter how wild it is more likely than intelligent aliens coming to visit us. Anything is more likely than that. So you'd have to.
No.
Let me give you.
Yeah, go ahead. Finish.
There are lots of reasons. First of all, as I told you, the likelihood that why would they come here? Because they don't know we're here, and we're not particularly interesting. So as you just point out, they'd only know we're here if they've been within 100 light years of here. But in order to get here, they have to be traveling near the speed of light. and then as I pointed out, even if you use fusion, or even if you use matter antimatter as your fuel, then every time you want to start and go to half the speed of light and stop, you'd have to find, in that case, I think it was something like 16 times the mass of the spaceship in fuel. And there's a lot of antimatter out there. And so, and if you use fusion, you'd probably need 6,000 times the mass of the spaceship in fuel just to get to half the speed of light and stop. If you use conventional fuel, like rocket ships, you would take more fuel than there is in the entire visible universe to get to half the speed of light and stop. And so I have a hard time thinking of some alien civilization. You need to harness the power output of a star, basically, to take a spaceship that would hold beings, that, a big spaceship that would hold beings like us, and or not like us necessarily, but massive beings. And I have a hard time thinking that some civilization would harness, even if they could, would harness all of that energy just to come to the Earth to abduct psychiatric patients of some psychiatrists and do weird, kinky experiments on them. It just seems like an awful waste of energy. And so, just the energetics of coming in a spacecraft to us make it highly, highly, highly unlikely that that's happening. And then there are many other aspects.
But you're right. You're right in that. But this is where, and I don't have the answers, Lawrence, but this is where I apply this thought.
Okay.
We understand what we can understand today, right? That's our it gets, okay. All right. But ET, some extraterrestrial advanced civilization, more advanced than us, isn't going through a difficult process like that to do things. They do it because it's easy, and they figured out stuff that we simply don't know about, period. No. And that's my take.
Yeah, I know, but here's why you're wrong.
I don't think so. But go ahead.
One of the biggest misunderstandings about scientific revolutions is that they do away with everything went before them. Today we think this is true, but tomorrow it's all going to be wrong. That never has happened. Newton is still right. Okay, he's been supplanted by Einstein at the large scales and quantum mechanics at small scales. You take a ball 1 million years from now, whatever we learn about quantum gravity, and you let it go and it's going to fall just like Newton told us. So whatever we know about the universe, it's not going to suddenly change the physics that's right, that works. It's got to somehow subsume Newton, like relativity does at large speeds, or quantum mechanics does at small scales. It reduces to Newton on the scales of you and me and cannonballs and spacecrafts. So whatever some fancy civilization is going to come up with, it's not going to be able to avoid the simple things that we know are true about the universe, about energetics and motion and the speed of light and the challenges of moving at the speed of light. So
but doesn't entanglement
miracle, even take Cosmos or take Contact, Carl Sagan's book. Yeah, so maybe they'll find wormholes that somehow are shortcuts through space. Well, yeah, except we've already, and Kip Thorne was the first one to do this calculation, I think. But wormholes are shortcuts through space, and that's what Jodie Foster took in Contact. Wonderful, except it turns out the laws of physics that we know to be true tell us that wormholes in which you could travel through the mouth of the wormhole will collapse to form a black hole, each mouth, and at times go shorter than it takes to get through it. Unless you could find...
But doesn't entanglement overcome, the ideas of mass and the speed of light?
Can what?
Doesn't entanglement overcome...
No, that's a misunderstanding. Entanglement, nothing, not even it. You can't transfer information faster than the speed of light, even with entanglement. It's like a cosmic catch-22. It is true. Entanglement says that if I have two electrons that I arrange in a very specific state, one, let's say, pointing up, one pointing down, but they're there are many possible states, but they're all, whatever state they're in, their spins are their angular momentum are pointing in opposite directions. So it could be one of many different possibilities, right? And so then you separate them, and they're still correlated like that, right? And then you measure one. I measure this one, and I find out it's actually pointing this direction. Instantaneously, that other one, we can say that other one must be pointing down, not to the right, not to the left, not up or down. If this one was measured up, instantaneously, it ensures that other one, if I could do my hands down, is pointing down. And that sounds like, hey, you're sending information faster than light. Well, I can communicate faster than light, but you can't. Because what does it mean? Well, if they're doing this, and you measure one of the electrons, you're going to find 50% of the time it's pointing up, 50% of the time it's pointing down, right? And so it is true that if I measure this one pointing up, an observer somewhere else will always measure this one pointing down. But remember, if this observer measures 50% of the time this, and 50% of the time that, and this observer will also measure 50% of the time this, and 50% of the time that. So there's no information transfer. The only way you could get information transfer is if this observer over here phones this observer over here and says, guess what? I measured that electron. The one you're about to measure is pointing down. But of course, that phone call has to be at less than the speed of light, right? To get that. So entanglement sounds like, it avoids the causality, the rules of Einstein and causality, but it doesn't. You can't transfer information faster than light. Sorry, it's one of these cosmic catch-22s. And so, while it is true that the laws of quantum mechanics allow what appears to be instantaneous things, and it's true that on Alpha Centauri, if one of those electrons ends up there and you measure it here, it instantaneously affects what you might be able to measure about this electron on Earth. But the reason that seems so strange is we classically think of those electrons as separated. But quantum mechanically, they're not. They're just part of one quantum mechanical wave function. And it's just part of the fact that we think of the world the wrong way because we're classical beings. And they're not really separated. They're part of a single object, and the properties of that object are determined by quantum mechanics.
But if you change the state of one and you change its spin from up to down, does this one then change its spin?
No.
So they're not entangled.
Well, I mean, once you, that's the point. They're entangled until you do something to this one. Right. Until you and if you knock it in another particle and change the state, it's no longer entangled with that other one. And so, and that's the other property of entanglement. It requires you to very carefully prepare these states and make sure they haven't been interacted with anything else on their long voyage across the cosmos. Otherwise, they're no longer entangled. And that's why entanglement is so weird, because for us, things are interacting all the time, and these quantum correlations disappear. And that's why in the classical world, you don't see that kind of strange behavior. And so quantum mechanics is very special, and it is very interesting, and we can do neat things with it. And if we specially prepare systems, and we'll be able to use it to do kind of really neat error correction, looking at checking for for someone security, quantum security of systems, to see if someone's eavesdropping, all sorts of neat stuff, and quantum computers. But it's not going to allow us, unfortunately, to violate the fundamental laws of quantum mechanics or physics. So sorry, it would be nice, but it's not the case.
In your book,
but that's the way it is.
In your book, I'm here to learn. In your book, A Universe from Nothing, really helped me, and I'll tell you why it helped me in a very fundamental way. When the Big Bang is talked about, I think that the majority of the people that don't understand it assume that all matter was originally compressed into right, and then it came out. But no, it came from reactions, right? Okay, so if that's the case, is every particle in the universe entangled if the original reactions started?
Because it's certainly not entangled. No, it's not entangled because it was a hot dense universe, and that meant there were interactions happening all the time, and any quantum correlations in a thermal bath get completely wiped out. There's no information left. It's just got a temperature. You can't imagine a less entangled state.
Now you're breaking hearts. Now you're breaking hearts.
Well, then I've done my job.
And now let's steer this into 3i Atlas.
Okay.
It's without bringing up Avi Loeb, and we will later.
Well,
But
we have to. What can I say?
yeah, I like Avi.
Well, I've known Avi for maybe longer than you. Yeah, but I think he likes. Well, anyway.
Okay. I'm leaving Dawkins alone, so we'll leave Avi alone. Okay.
No, we have Avi's fun. Avi's fun to attack, so it's okay.
Yeah,
he can handle it.
But here we have an opportunity to observe and collect data on an interstellar object. There's a lot of claims right now that are going on with these observations. So what is your take at the moment?
Well, my take is that it's it seems to be a comet, and like anything else, and it's from outside our solar system, which is neat, but it's certainly emitting a lot of water, which comets do when they, maybe there's maybe these people are drinking a lot and peeing a lot on the spacecraft, but it's emitting a lot of water like a comet does, and once again, extraordinary claims require extraordinary evidence. It's much more likely that it's a comet than it is. I mean, there's no evidence that it's anything intelligent. Sure, it's behaving a little anomaly here or there, but that happens all the time when you see things, because we learn how things behave in space, and there are lots of anomalies. And so to jump to the conclusion, as I said once again, with referring to Feynman in a way, to jump to the least likely conclusion of all the possibilities, and there are so many of them, to pick the one that we like, but it's probably the least likely, is the least scientific. Okay? And to assume that, you'd have to have a sliver of evidence, not just a sliver, but a mountain of evidence, because it's so extraordinary. And there isn't any. So why take this object, which is like other objects in the universe, and we know of lots of comets in our solar system, and we know lots of objects can be expelled from their solar systems. Why to immediately jump to the possibility that it is an alien spacecraft, deciding somehow that our solar system is interesting enough to explore among the 100 billion solar systems in our galaxy? Why to jump to that conclusion is like jumping to the conclusion that there's a teapot orbiting Jupiter. I can't disprove it, but I'd suggest it's highly unlikely.
Well, we want contact,
and
it's
course.
A fun thing.
That's the point. That's the X-Files, right? The X-Files mantra is, "I want to believe," and we should realize, and this is what science teaches us, we all want to believe. I would love there to be life. I'd love contact. I'd love it. We all want to believe that, and when we want to believe something, that we should be most suspicious of our beliefs, because we'll look for anything to confirm our beliefs. It's the way humans are. And science teaches us that the things we believe in the most are the ones we should be most skeptical of, because we're so willing to believe. And good scientists have learned that. I don't know how many experimental scientists have published wrong papers because they saw an anomalous result and decided it was significant, instead of saying maybe it's an accident. And let's look at the possibilities. And again, to take Feynman, who was just a great scientist, he used to go to people and say, "You won't believe, you won't believe what happened to me today. Just won't believe what happened to me." And people go, "What?" And he go, "Absolutely nothing."
Right.
And because you can dream, you can have weird, nutty dreams for 1,000 nights, and then one night you dream that your friend breaks their arm, and the next day they broke their leg, and you. But you don't forget that you had 10,000 dreams and they were all nonsense, and one of them happens to correspond closely to reality. It's an accident. But none of us like to believe what happens to us is accidents. Let me give you another example that relates to, say, religion. Take the miracle at Lourdes, Lourdes, France, where the people are cured of things by the Virgin Mary, who appeared in this fountain or waterfall or whatever. So every year there are literally millions and millions of pilgrims who go to Lourdes, France, to be cured. And the Roman Catholic Church keeps good, accurate records of this. I learned this from Carl Sagan years ago. So, they worked out over the past, I forget how many, N years, 150, forget the number. There was 120 million pilgrims that had come through. Okay. No one ever regenerated an arm or leg. Okay. But there were maybe 20 cases they couldn't explain of people who say had their cancer ended. Okay. 20 out of 120 million. Spontaneously, the cancer went into remission. But it turns out in the background population, spontaneous remission of cancer occurs at a higher rate. Say 200 every 100 million people. So in fact, if you go to Lourdes, look at the statistics, you have less of a chance of. But if you go to Lourdes and your cancer goes into remission, there's no way in hell that I'm ever going to be able to convince you it was an accident. You're going to say it was a miracle, because we all believe.
Do you believe in ghosts?
I don't believe in anything. I don't like to use the word believe. It means nothing.
Right.
Things are either likely or unlikely, and certainly ghosts are unbelievably likely that we can say with reasonably certainty that they don't happen. But so that's the way to think of things. What are the likelihoods and what are the unlikelihoods? But as I say, if something strange happens to you, you automatically think it's significant. If you see something in the night sky, if you see something out of the corner of your eye or something, it's got to be ghosts or aliens or, in the ancient world, fairies. I mean, that's the other thing that's really interesting. If you go 200 years ago, when people saw weird things, it was fairies, because that was the culture of the time. Now, when people see weird things, it's always the aliens that look like on your fade to black, except for the hair. Always a big forehead, big eyes. Why does everyone see the same thing? Because they've seen it on the internet, and so many that when they dream or whatever, that's what they see. So people don't see fairies anymore. What happened to all the fairies? Well, culture changed, and the weird things people now attribute to something else. Highly suggestive that these are creations of the human mind and not of nature.
I ride a Harley, but fairies are real. So check this out. I want to run this by you. I was up in the Pacific Northwest. I'm at Mount Adams, which is a dormant volcano. Beautiful,
I've been looking
right?
at from my house here in the Pacific Northwest.
Anyway. So you know where it's at. So I'm up there. I'm about 14 miles away, just outside of the Indian Reservation, with 300 of my friends, and I'm doing a Fade to Black conference up there.
Okay.
And while the conference is going on, I'm outside. And I know this is going to sound crazy. I'm just going to tell you what happened. So I'm outside with about 30 people. I'm sitting at a picnic table with a pair of binoculars on a small tripod. I'm looking at birds. And it's beautiful up there, right? It's beautiful. And in the background is Mount Adams. But I'm looking at the birds. And then all of a sudden, it's the only time this has ever happened to me. I still can't explain it. From behind Mount Adams, here's the peak. From behind Mount Adams, it's 40 miles away, comes this giant beer can. And I'm going to say, if I'm going to guess, it's 14 miles away, but I can see it in the binoculars. It's big. I'm going to say 500 feet tall. And it's like this, Lawrence, and it's spinning, and it's moving through the clear blue sky. I was like, what the heck is that? And it's black, and it's like a silver top and a silver bottom, and it's giant. It's the size of the Empire State Building. It's like crazy big. And it's from behind Mount Adams, and it's moving really slowly. And I observe it. I jump up, and I yell to everybody, pictures, pictures, video, video. And I come back 5 seconds later. I come back, and I'm look at it again in the binoculars, and and it's in focus. The sun is shining on it. I can see it spinning. There's like a circle on it, and it was spinning. And I just look at it from top to bottom, and I put it on my frontal lobe. And I come out and I look at it, and it's just a little dot, but I could see it spinning and the sun reflecting off of it. Everybody's freaking out. And as I come back to the binoculars to look at it, the person sitting to my right says, it phased out. It disappeared. what? And I look, and it's gone. I thought it was going to be up there for about an hour, as slowly as it was moving across the sky. And I come back, it's gone. It's gone. Now, I don't know what I saw. I don't. I have no clue. I can just tell you what it wasn't. Right? It wasn't a plane, it wasn't a helicopter, it wasn't a rocket, it wasn't a balloon, it wasn't this, it wasn't that. It wasn't anything like that. In fact, it was so strange. You know what I mean? It wasn't like a flying saucer or some mothership or Independence Day. No, it wasn't any of those things. It was this thing, right? Like this spinning across the sky. And I came away from that saying to myself, I don't know. I'm a member of the media. I'm in a position to talk about these things, and I am going to try to figure this out. That I can't explain. And so when you observe something like that as a physicist or a scientist, how do you turn around and try to explain that and rationalize it so you don't jump in the deep end of the pool?
Well,
like
it's hard not to, because once again, what happens to you, you're convinced it's significant. The first assumption is that somehow your eyes were fooled. I do magic. I could do N magic tricks for you right now that would astound you. But of course, they're all tricks. But you would see things that are impossible. You would see them. You watch me do something that is impossible. So we're easily tricked. And our eyes particularly are tricked all the time. I see weird things. And so once again, I can say to you that that there's lots of possible wild explanations of what you saw that aren't what you saw. But as a scientist, what I would do is say, well, this is really weird and I can't explain it, but I don't understand what it is. But then I jump to the most likely possibility, not to the most unlikely possibility. And I try and rule out, and I look and try and understand how I can rule out all the likely possibilities before I get to the most unlikely possibility. And I think that's the important thing. But everyone bypasses all those steps. It says, no, I want it. It's obviously the product of intelligence, and it's obviously and if it's obviously the product of intelligence, it's not some intelligence here on Earth. It's got to be some intelligence out in the universe. And how you make those leaps of faith are they're not beyond me, because I understand how people do it, but it's not scientific to do it that way. And I understand, so I see lots of things I can't explain every day, and that's what and that's wonderful. That's why it's worth doing science, but I guess the other big mistake people have about science is that because we don't understand everything, we understand nothing. And that's not true. We understand an incredible amount. And whatever we don't understand has to somehow fit into what we do understand, and we have to reduce to it. You can't predict things that are disagree with the experiments we've already done. And so you have to use that as a guidepost, and it's strongly constrained. Science is imagination in a straitjacket. That's where it differs from science fiction, because the straitjacket is reality and experiment. And you're constrained by that, much as you would like. And that's why scientists may seem not open-minded, but once again, they're constrained within the straitjacket of the vast mountain of knowledge, of experimental knowledge we have about the universe over the last 500 years of the Enlightenment. And whatever we see can't disagree with the results of that body of knowledge of how the universe actually works. So I can't tell you what that was, and I can't even tell you that you were wrong, that it wasn't something weird and extraterrestrial. But all I can say is,
I'm not saying that.
You're not even saying that. But all I'm saying is, understand that you don't understand what it was, and then start thinking about the possibilities, and then try and figure out how you do an experiment to distinguish between the different possibilities. And only when you ruled out all 999,999,999 other possible explanations can you then say, oh, well, it's extraterrestrial intelligence. And that's the problem of this comet. Jumping to the least likely possibility with no evidence whatsoever, simply because you can't explain all of its motion. This has happened before. The problem is,
what about the self-illumination part?
And it's happened before with Avi, with that other extraterrestrial. Oumuamua or whatever I can never pronounce it right. Oh, look, it's behaving strangely. I tell people explain the strange behavior. And so, you think once burned, twice shy, but that not Lavi. So
Have you read his book, Extraterrestrial, about Oumuamua?
no, I haven't. I've known Lavi for a long time, and we were on Breakthrough Star Talk together. We were working along with Stephen Hawking and a few others, trying to develop a little teeny starship that will go 20% the speed of light to get the nearest Alpha Centauri in 10 years. So I know Avi, but I think I also, yeah. So I know some of the claims, and I know a lot of the counterclaims, and I have a certain amount of time to read things, and I decided that wasn't one of the things worth reading. And I'm very, I'm happy for Avi if it helped him buy a new house or whatever it did. But I know, and look, Avi's full of lots of interesting ideas, wild ideas in science, and some of them have been right, and some of them have been ridiculous. And he produces all of them, and that's great. Good for him.
The one thing we need to take our break, and we'll jump into that right now. The one thing, and like you just said, Avi, I know Avi, and I broke bread with Avi, and I've had a lot of conversations with him. He doesn't go woo-woo.
Oh yeah, I know.
And he will constantly say, look, man, it's just the data. When I say something, it's based on the data. I'm not.
He's basing on the data that something's unusual, and then he makes a claim based on the data, which unfortunately has turned out enough times to be wrong. So what can I say? I think, as I say, Avi is attracted to lots of interesting explanations of lots of stuff, and sometimes they're right, and sometimes they're wrong. And I think he's a very creative, imaginative, capable man. And so I think he looks at the data and sometimes comes up with claims that are not right. And the great thing about science, about making such claims, is that you open yourself up to other people to explore them. And that's how science progresses. So it's fine. If his claims cause other people to do work that then demonstrate that explanation doesn't work, fine. The problem is, especially with the media, is that the claim gets the media attention and the counter result doesn't. And so, the way science works is, extraordinary claims are made and people look into it and find out that they're wrong. And you, too often, the finding out they're wrong just never gets reported. And I think in this case, in all the cases that Avi has been talking about, from the existence of this Oumuamua or whatever it is as an alien spacecraft, to the evidence that somehow, nodules, extraterrestrial nodules are discovered on the ocean floor. All of those claims haven't panned out. So it's suggestive. Let me put it that way.
Well, we'll pick this up when we come back. Lawrence, you stay right there. Our guest tonight, Lawrence M Krauss, talking about cosmology, the universe, physics, and of course, 3I Atlas. All of that and much more. Lawrence, stay right there. I am your host, Jimmy Church. This is Fade to Black. Stay with us. Subscribe to our YouTube channel to get your alerts and access to over 2,000 videos. Click that subscribe button right now. Go to jimmychurchradio.com and get the Fade to Black official podcast. 2,000 episodes, all of them commercial free for just $2 a month. Watch Into the Vortex on Gaia TV. It's Fade to Black for the screen. Simple to do. Go to Gaia.com, search Jimmy Church, or click on the link below. Follow Fade to Black on Twitter at JChurchRadio. Get all of the show updates every single day. It's now called X, but who cares? How you doing? Jimmy Church here. Special announcement. Get your Fade to Black t-shirts. That's right. Help support the show. Help support everything that we do over here. We've got 2 t-shirts. We've got 2 ways to get them. Get your Fade to Black t-shirt today. Go Backley Tappy. Go to jimmychurchradio.com and become a Fadernaut. Get a membership. That's right. Everything is commercial free. You have access to downloads, and you get to call yourself a Fadernaut.
Jimmy Church Guy TV, Fade to Black, here at Machu Picchu with Brian Forster and Hidden Inca Tours. Amazing tour so far, Brian, but we're here to announce what we're going to do next year in 2026. What's going on?
Okay, November 2026, we're going to have our major tour of Peru and Bolivia, either a pre or post tour of Paracas and Nazca on the coast. And then after that, 6 days in Easter Island.
Bucket list, Easter Island. Come join Brian and I and his amazing team here at Hidden Inca Tours for Peru, Bolivia, and Easter Island. Signing out. Say goodbye, Brian.
Bye, gang.
River Moon Coffee, makers of the Fade to Black blend. Truly the best coffee on planet Earth. Just visit rivermoonwellness.com or their Amazon store. It's all simple to do. You can check out the Fade to Black blend, the Game Changer blend, or any of their Black Moon Wellness products. It's the only coffee I drink. It is the best, and it's Doc. Again, rivermoonwellness.com.
All right. Welcome back. Fade to Black. I am your host, Jimmy Church. Tonight, our guest is Lawrence M Krauss. Great conversation tonight. Physics, cosmology, science, and of course, 3i Atlas and what is going on out there in the universe. Very interesting conversation about entanglement earlier, too, as well. And I have said many times on this show, I have changed. Doing now, approaching 3,000 episodes and having the best and the brightest on this show. For me, it's like going to college. I have spent 2, 3, 4 hours a night for the last 15 years interviewing the very best and the very brightest. And all I do is learn more and more. And I have changed over the years. And it's guests like Lawrence that I can access and get into a conversation, just sitting around, a dinner table, having a conversation and getting my knowledge on. I really appreciate all of that. And Lawrence, just thank you for your contributions and everything else. And
well, I have to say it's a lot more fun than I thought it would be.
Well, okay, we're not done though. We're not done.
I know, but it's good. But but it's good. I know I'm spending all my time explaining why ghosts aren't. Anyway, go on.
Well, I remember seeing you. I don't want to jump into this, but I remember seeing you and Dawkins and a couple of others. You guys were doing a thing. You guys were on tour or whatever.
Yeah. Mm-hmm.
And I remember Dawkins said on stage in front of you, he goes, "Well, man, I'm afraid of ghosts. I won't go into a haunted house." Right. And I remember him saying that. Well, you can't have it both ways. But I understand.
I don't remember that, but I might have blocked it out. It was so traumatic.
Right. Okay, I want to go down a few points and get your insight on this.
Okay.
On 3i Atlas. The first point, it appears to be self-illuminating. And everything that we know about comets, right? This isn't fitting into those things. It's not to say that the universe is, it's ginormous, and there's all kinds of things we haven't discovered or observed yet. But that self-illuminating portion of this, what do you make of that?
I'm skeptical. How do we know it's self-illuminating? How do you know? Because someone told you it's self-illuminating? I mean, how do you know? I'm extremely skeptical. I mean, you have to know a lot to know it's self-illuminating. You have to know it's albedo. You have to know it's albedo to see what light is being reflected from it. You have to know what processes are happening on it. I mean, here's another. There are lots of mysteries that we don't understand. Jupiter, for example, seemed to be, and still is, I think. I don't think this has yet been fully discovered. I once came up with a ridiculous possible explanation, which I don't think is right. But I think Jupiter is emitting more energy than it should. It seems like there's energy being generated. Jupiter isn't a star. The Earth generates a lot of heat. Is heating up the space around it and releasing a lot of energy. But we understand it because its core is hot. But Jupiter has this hot core, but it seems to be emitting more heat than you would think comes from this core. So that's an anomaly. We don't think the Wizard of Oz is at the center of Jupiter generating that energy. But I think you have to be skeptical. Here's an object that's difficult to measure, and you're first looking at it, and you don't know exactly what it is or what its albedo is. And so I'm skeptical of the statement that it's self-illuminating. I'd like to know what the evidence is, and no one's given. I mean, to be frank, I haven't spent all of my time trying to study it because I think it's the likelihood that it's anything but a comet is so small, and I know there are a lot of people doing this anyway. But I think that the likelihood that the claim that it is self-illuminating is true is very small.
The other claim, staying on this part of the question, is that it seems to be this is just what I have read, that the light is on the front of the object and not from its tail. And that seems to be anomalous and a bit strange too as well. And again, where this data and how these conclusions are there, I don't think we've collected enough data yet to.
I'm actually looking at because I knew you were going to ask. I was looking at some of the. I mean, I actually in the spur of the moment because I didn't know what the program was going to be about, but I kind of guessed. I'm looking at it, and the Mars orbiter is looking at it, and I look at it. It says that there's not enough data to be able to even determine its composition or makeup of the object, and so it's very tentative. The Mars Express images have not yet captured with its cameras, and it's looked at the spectra of the comet using its two spectrometers. It's not yet clear whether the two orbiters gathered enough light for a proper characterization of the comet's composition. So it's great. We're gonna learn a lot. But the claim that we know all these features of an object that we're just beginning to see is just, I think, people jumping to what they want to believe rather than what may actually be there.
Now, what about, and you understand comets and cosmology certainly more than I do, but the early spectroanalysis is indicating a high composition of iron and aluminum and other things, and that the comet tail may be comprised of aluminum and metals. Does that represent what you know of that is typical of a comet?
No, but why do things have to be typical?
But that's what makes it so fascinating, isn't it?
Yeah, but again, the information I have, which is not a lot, and I could be wrong in this, but when I look at this at sort of reasonable scientific publications, what I get is it's tentative, and we don't even yet know the real composition. So, my attitude about this is let's wait and see.
You brought up.
You don't understand. Let me give you a perspective.
Sure.
Here's
why you have a beer belly, even if you don't drink.
Take quantum electrodynamics, which is the world's best, our best theory of nature. It's the best tested theory. We predict things to 12, 13 decimal places, and they agree with observations. There's nowhere else in science we can do that. The first experiments that were done in quantum electrodynamics have almost always disagreed with the predictions by 2 sigma. And so the very first time you do something, when you're just learning how to do it, it's quite possible that you're wrong. And therefore, you have to be very careful when people are doing complicated observations for the first time to suspect that claims that are made are right.
You brought up Carl Sagan earlier and the movie Contact.
Yeah.
And the first couple minutes of the film, to me, are the most special, which is a pullback from planet Earth, right? They pull back, and then you see how insignificant we turn out to really be, and how the Milky Way just turns into a dot. And now we know what Hubble did, and the telescope and the deep field observations and everything about how many galaxies are out there.
Yeah.
But in that, you see very quickly how large the universe is. And that's one of the things that was so magical about the movie Contact. But based on that, in the last 5 or 6 years, suddenly we have 2 interstellar objects that have come in and found us and our sun and orbited on our ecliptic and then left. And the odds of that seem pretty extraordinary.
Why? How do you determine? Let's step back. Why? Why do the odds of that seem pretty extraordinary?
I just told it.
Maybe
the movie Contact showed. I mean, the odds.
I know. There's lots of stuff going on. Where our sun, our solar system is traveling at 200 kilometers per second through the galaxy. Okay, and it'll take a few 100 million years to go around the galaxy. Okay, and at that rate, and so we're moving through the galaxy. There's lots of stuff, and let's think about the selection effects. So let's say an object passes through it perpendicular so fast that, and it's going so fast that we don't have enough time to detect it. What's the selection effect? Selection effect is if you're looking for things, the things you're going to see are those that are likely to be on a trajectory to keep them in the solar system for the longest time. So you put that selection effect in, and then you say, isn't it amazing that the things I'm seeing are that? So I think when one argues that the odds of something are very small, you have to think about what that really means. What are the total? We got to ask, what are the total locus of possibilities? What selection effects are you putting on them? For example, the odds, if you actually worked out the odds that you and I are having a conversation today and did it by probabilities, well, it's impossible. I was driving there, and the stoplights happened to happen exactly the right time, so I'd get home in time to be, and the day before that, and the day before that, and my birth and your birth at that instant, it's impossible, right? But rare things happen all the time in a universe that's big and old. And so, but when and there are people and Richard and I have had to do with a lot. There are people who are arguing it's impossible that life could have ever evolved naturally. Just think of how impossible it is. Well, who says it's impossible? And there's been 4.5 billion years. And so when someone says that the odds are so unlikely, I ask them, how did you determine those odds? And what do you know that I don't know in order to determine the locus of possibilities? And as I say, let's think about what you can see. It's like talking about those extrasolar planets. What we've discovered are this remarkable fact that there are a lot of gas giants that are not far away from their star, but are close to their star. Isn't that weird? Well, yeah, except the easiest planets to discover would be gas giants that are close to their star.
Exactly.
So it's not too surprising that that's what we're seeing if those things exist. Now, what's surprising is that they exist, but now that we know they exist, it's not too surprising. Those are the ones we see because the selection effect will give us that. So you always have to think about first background probabilities and what your selection effects are, and you have to be willing to say that what seems very strange and odd is just an accident that's not too surprising.
Well, Lenny Susskind said, well, many people have said this, but he says it in such a way that I just enjoyed it a lot, which is this.
I like Lenny. And
anything that can happen will.
Yeah, well,
your craziest thought, right? Your craziest, most insane thing that you can think of could happen tomorrow.
As long as it doesn't violate the known laws of physics.
That's right. That's right.
Well, anything that can happen does happen. I've said it, I've said it as well. In a universe that's big and old, rare events are happening all the time. I mean, in our galaxy, a star explodes once every 200 years. And there are 100 billion stars in our galaxy. It's very rare. But if you look at the universe, a star is exploding every second.
That's right.
Okay, and so
then isn't it equal then? The Dawkins version of how life started and an extraterrestrial spiritual intervention created life? Don't they weigh the same then?
No, because one requires a lot more assumptions than the other. After all, this is the one thing
the natural side is the one you have to take all this.
Here's a big flaw with that argument. And Richard has pointed this out. So we're created by aliens, by advanced aliens, okay? But then you got to ask the question, who created the advanced aliens? They're a lot more complex than us. So did they evolve naturally? Were they created by yet more advanced aliens? And is it advanced aliens all the way down? I mean, it begs the question. And when you think about it that way, you say, well, then maybe there's a problem with that picture. Because if they evolved naturally, then why couldn't we evolve naturally when we're less complex? So once again, I think if you think about that correctly, you find, and then I use that argument for the Matrix as well and all the rest. I mean, if we're in some video game of advanced aliens, are they in a video game of yet more advanced aliens? Is it elephants all the way down? The famous example, the story of the world being held on the back of an elephant. Well, what's holding up the elephant? Another elephant. And then what happened? What is it? It's elephants all the way down. Anyway, so you see, once again, I think that argument, doesn't hold water when you think about it correctly, in my opinion.
I just stay objective. I stay in the middle. I don't have all the
answers. I'm staying objective. I'm asking what's likely and what isn't. And I'm willing to be proven wrong. I love being wrong. That's what the property of the scientist is. I love being wrong because it means nature has I told you, the imagination of nature is greater than that of human beings. That's why I do science. Because nature is, I like to say every day I'm surprised if I'm not surprised. And so it's great to be wrong. But at the same time, you've got to look at something and say what's more likely and what's less likely and analyze things that way before you can discover you're wrong or before you discover that the least likely possibility is true. It's like Sherlock Holmes. You get rid of everything that's wrong and what remains is right. So I tend to think I don't think I'm being closed-minded or not objective. I think I'm ultimately willing to accept any possibility as long as but weight it according to some set of priors of what's likely and not likely based on what we know already to be true. And then to explore ways to find out if I'm wrong.
So an object appearing, two interstellar objects that we know of, so closely, on a calendar, so tight.
Well, now you have to ask, but hold on, let's stop. But then you have to ask, would we have been able to see these objects without the technology that we have today?
Exactly my point.
Isn't it surprising that we can now, that they're happening when we can see them? No, it's exactly what you'd expect.
So do you think it has been common over the last 4 billion years that this is happening all the time? We're never able to observe it? Right.
All I know is it's not surprising that when we can see them, that they exist. If they exist, when we can see them, that's when we see them. So once again, thinking in that way, what seems to be a mystery or suspicious is not is not that surprising at all. It's looking under the lamppost. Okay.
Okay, so let's suppose something.
Okay.
3i Atlas turns out to be artificial. It even sends us a radio signal, says, "Hey, what's up? We love I Love Lucy." Right?
Mm-hmm.
Okay, so that happens.
Of course, you gotta ask. By the way, let me just point. I can't resist. If it really were artificial, why does it have to be in our solar system to send a radio signal? Because it can send a radio signal from its own planet, or even halfway here, or a third of the way here, or 5 times the distance of the. If I'm in a plane, I don't wait till I'm right over the runway to send a signal to the ground control that I'm here. And so once again,
it would do it because
moreover, the reason, as I argued in the Beyond Star Trek book, if you think about how much effort and work and energy and money would be required to send an extraterrestrial object here of any reasonable size, it's just so much cheaper to send the telegram. And so it's much easier for me, as I used to say, I think in my book, to download the plans of a Ferrari than to download the Ferrari.
Well, but they would know that we are the trailer park of the universe, right?
Why?
And so they would know that it would be they would have to come by and say hello to us.
Why? As soon as they're 100 light years away, they know they know what our technology is.
Yeah. So how would they observe us though? Do they observe us as bacteria, or do they observe us as being somewhat intelligent?
Well, obviously, I think, let's go to Star Trek. One of my favorite episodes that, they're listening for they hear a tapping and the tapping comes out to be the first 6 prime numbers, which is, by the way, the first thing that SETI was listening for was prime numbers. Why? Because if you know the prime numbers, it means you know mathematics. If you know mathematics, you're intelligent. And so you look for something that demonstrates intelligence, and one of the ways is mathematics. So I think, or technology, right? Radio waves, demonstrating radio signals requires that you know the laws of electromagnetism, and you can generate, generate antennae and modulate signals and do all sorts of things. That requires intelligence. So I think it wouldn't be pretty hard. It would be pretty easy to distinguish intelligence, at least in the form that we normally think of it here on Earth, from non-intelligence, right? I think
what if ET says to us though, that math thing, that's old. We don't really deal with that anymore. It's about colors and consciousness.
Now, I think I would say to them, well, it's pretty weird that math seems to not only it seems to be the language of nature, and isn't it a weird coincidence? Somehow it's a cosmic conspiracy that every law of physics is described in terms of mathematics, and that mathematics allows us to unambiguously predict how the universe works, and it's continued to work. But it's just a complete conspiracy. It's really not mathematics. Well, maybe, but again, you'd have to convince me that there's a conspiracy, and colors, after all, are really nothing other than mathematics, right? Because colors are just frequencies. So we see them as colors, but of course they're just different frequencies of electromagnetic radiation. So they're really described by mathematics, and then the fact that we see them as colors it's an accident of our evolutionary existence. You say, here's another thing. Here's another remarkable coincidence. The sun emits, the temperature of the sun is such that it emits most of a great deal of its energy, if not most of it, in this visible spectrum. And isn't it amazing that we're sensitive to visible light? Well, the obvious answer is that evolution would, have a system that would be sensible to the light that's coming in from the sun. So it's not too surprising that we're sensitive to the and moreover, radiation in the extremes is screened out by the atmosphere. So high X-rays are, and a lot of cosmic rays, and so it's not too surprising at all that evolution selected.
You almost sound spiritual right now, Lawrence. I'm just letting you know that sounds very spiritual.
Why?
Let me.
Why? No, I'm just saying if a system, if life is going to explore a configuration that allows it to reproduce, then having sensory systems that effectively allow it to detect the dominant forms of radiation, so that it can understand explore its surroundings, is pretty probably evolutionarily preferred. And so if lots of other organisms developed that couldn't do that, and ones developed that could, they're most likely to outcompete the ones that couldn't. And in that sense of natural selection, it's not very surprising at all that now, of course, as we also know, certain life forms are sensitive to much broader spectrums of light than humans. So it's not unique in that sense. But what's true, I think, and I could be wrong here, but I believe that even bees and other things that can detect ultraviolet light and other things, it's not that they can't detect visible light, it's that they see a much broader spectrum of light. And so it would be interesting to see if there was it would be surprising, but not impossible, to find a life form that could detect only non-visible radiation. That had us, obviously, there are such systems, probably, single cell molecules probably can detect heat, and avoid hot things. But ones that have sophisticated sensory organisms, you'd think would, if they're sophisticated enough to quote unquote see, then it'd be hard to imagine that they couldn't at least see visible light as well as other things beyond visible light. But that's a speculation, and you can test that speculation, and that's great, because if it's wrong, that tells you something you don't understand. And that's what's great about science. So I'll make that hypothesis, and I think it's very reasonable, and I want to believe it to be true. But if I go out tomorrow and find a life form that doesn't do that, then I know it's wrong, and then that tells me something more interesting. It tells me that something about my hypothesis is wrong, and there's something I didn't understand, and I need to understand more. That's what's great about science.
Eventually, our sun, I think it'll be sooner than later, but is going to be unstable, and we're going to have to blow this popsicle stand.
Well, it's going to, it's not sooner than later. My favorite, you may have heard.
Well,
can I tell my favorite science on stage? You may have heard me say this on stage many times, but my favorite science joke is someone like me says the sun's going to last 5 billion years before it exhausts its hydrogen fuel. It's going to become a red giant. It's going to engulf the Earth. And someone puts up their hand and says, "Did you say 5 million years?" And I say 5 billion years, and they go, "Whew." Okay. I mean, the point is that it's a ways away, so you don't have to worry.
It's a ways away. Now, whatever that time scale is, whether it's 100 billion years or 5 billion years or 1 billion years or 100 million years.
Yeah.
But eventually we have to split. And when it does become unstable, our atmosphere is blown away and the temperature here is 2,000 degrees and there's no water or anything left. There's going to be nobody here to observe a red sky that is full of the sun. We're going to be gone.
Well, I mean, not only will be full of sun, but we'll be inside the sun.
It will be inside the sun. Yeah.
Unless we decide, unless there's enough time for us to figure out how to move the Earth to where Mars is. Right now, it's not very hard to do. If you have a few billion years, there's simple ways to slowly move the Earth out. So if civilization survives, I think the Earth could actually move its orbit. But anyway, or at least humans could move the orbit of the Earth, or intelligent, or robots, or whatever is the dominant.
We have to do something, no matter what.
We have to do something.
We have to do something. So now, if just based on what we know now, in what I have understood about our future, is that life out there, depending on what their star is, right? But life out there that is going through the same experience of instability in their sun, or has already gone through that, then they would have left their planet too. And eventually we are going to do that. So why, in the size of the universe, why is it such a crazy thought that there may be life out there that has left their planet, just like we will have to do one day? I don't think that is just some crazy, extraordinary thought. I think it's probably happening a lot.
Well, it may or may not. I mean, first of all, once again, we have to do that once every 5 billion years. Okay, our galaxy is 12 billion years old. So it doesn't have if life evolves around stars like our sun, whose life cycle is 10 billion years. And it's 10 billion years, right? The life cycle of the sun, and before it becomes a red giant. Then that's basically once in the history of the galaxy that people have to move. So it could be that most. The interesting thing is that most stars are smaller than our sun, and the lifetime of a star, of hydrogen burning in a star, goes as the inverse cube of the mass of the star. So a star that is 1/10 the mass of our sun lives not 10 billion years, but 10 trillion years.
Mm-hmm.
And so civilization where that'll never have to leave. Okay, at least in the history of our universe, which is only 14 billion years old. So it's not obvious that that's required a lot. But even if it were true, you got to ask, well, maybe. Wouldn't it make sense instead, if a civilization was sufficiently advanced, to move their planet out to a distance so that around the red giant, their planet was in the habitable zone? Why?
But that
nothingness of space when you've got all these good real estate around you. Okay,
you're right. You're right.
Let's say there is. Hold on. Let's go on. But then let's say that you do decide to travel out there. Well, I mean, if it's random, our galaxy is few and far between. If you actually take a bow and arrow and shoot it, you're gonna miss. The likelihood you're gonna hit a star or a planet is very small in our galaxy. Okay, and in the universe as a whole, most of the time you'll just keep going. So you have to know where you're going to be heading, and once again, why here? So look, all of these things are possible. I can't say they're impossible, but why wouldn't you build if you have those infinite resources or large number? Why don't you build a Dyson sphere, or why don't you build something that's self-contained, that doesn't have to travel out in the universe, that can just exist in the region nearby your star?
Well, we wouldn't do that with our star, though. Our star at the end of 5 billion years is going to be a black lump of coal with
no, it isn't. No, well, it's going to be a red giant for a while.
For 5 billion years, but after that, once it goes through its oxygen and the helium stage and everything else that it goes through, it's gonna be nothing, and so there's no reason to move.
Our star is not going to go. Our star is not going to become a neutron star or a black hole. It's too small.
I said a lump of coal, not a black hole. A lump of
coal. It's going to be a white dwarf for a hell of a long time, for maybe 100 billion years, and so. And now all of that is longer than the current age of the universe. So, look, all of these things are fascinating, but and they don't preclude the possibility of other life forms have had to leave their solar system. But certainly, if they did, it's hard to imagine they'd be doing it in a little ship like 31 Atlas. It seems pretty small for a whole civilization to. I mean, and so. Once again, just examine the possibilities. Why not?
Yeah, here's the problem that I have personally.
Okay.
I think that we're being visited, but that's neither here nor there.
Well, I'm glad you think it, but you'd have to tell me why. But anyway.
We can circle back to that.
I haven't seen any evidence for intelligent life on Earth yet.
I haven't met it yet on Earth yet either. Is this though? With our ability to peer out, what we haven't seen is evidence of like interstellar trade routes or ships passing between. We haven't seen anything like that. And I would assume that we would see, I don't know if it would be nuclear trails or whatever it would be, but we haven't seen any evidence of that between stars yet. That's the one thing where I step back and go, or are they doing it you mentioned wormholes. Are they folding space like the movie Dune? I don't know. And we wouldn't see evidence of that. But that's the one thing we haven't seen any interstellar activity, interstellar trade routes.
Yeah, well, there's lots of things we haven't seen. In particular, we've seen not a single bit of evidence for any extraterrestrial in any way, in any form, any shape, any size.
No, you haven't seen.
Nor evidence of in any of the 4,000 planets we've seen, even evidence of microbial life, which are undoubtedly a lot more frequent. If life can evolve, it took 4 billion years on Earth to get it to us. So if life evolves, if it isn't unique here on Earth, and if it's ubiquitous, 99% of it is microbial, right? Hardly any of it is going to be able to get to the point of intelligence. So, but we haven't even seen evidence for microbial life anywhere else in the universe, much less intelligent life. So it's.
Have you seen the UAP and UFO hearings in Congress?
Why would I spend watching time? I've seen little clips from it, and what I've seen is absolute and complete nonsense. Obviously, people who are lying and don't know what they're talking about, because I hear people saying we've reverse engineered and it has to do with string theory, blah 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 blah. And I listen to it, and I know they're babbling about complete physics nonsense. And when I hear someone making claims about stuff that clearly is wrong, that they don't understand, I find the rest of their claims highly suspicious. So when I hear it, I know it's fallacious nonsense.
There were four military witnesses a few weeks ago.
Four. Woo-wee. That's great. I've seen more witnesses at a trial that get things wrong in a legal case. Moreover, these are people. You got to ask yourself, what's the vested interest in someone making a claim that you can't disprove, but gets them a lot of notoriety, maybe even a book deal? What's the likelihood that there's some self-interest in that? And that, by the way, that's for me, the biggest argument against having been visited is I know the way governments work. And if someone had real evidence of extraterrestrials having visitors, the money-making possibilities of that are so great. And you can't, governments are not good at hiding things. They're not, these vast conspiracies of hiding that we think we have, almost everything comes out. But here's one where a single person can make $1 gazillion. Here's an alien artifact. Let's look at it. Here it is. I've got it. Here's an alien. Here's a dead alien. Okay. So the fact that hasn't happened is extremely good evidence for me that it hasn't happened. Because if it had, I'm convinced that at least one person would just come out and say, not talk about things that can't be proved, but would actually present something that actually was real evidence. And so the fact that it hasn't happened because it's so lucrative is, to me, is the best evidence that it's never happened. Because they'd go on every program and they would instantly become rich. And that lure
that's always been my argument with that, for sure. And then we have something like at the last UAP hearing last month, Congressman Representative Burleson out of Tennessee showed a military video of an object shooting across the screen that they fired a Hellfire missile at, and the Hellfire missile bounced off of it, and the object just kept flying and cruising. And then when the Hellfire missile bounced off of it's pretty, I don't know what's going on in the video, but it's interesting to watch that 3 objects came out of the back of this object and then continued on its way. It turned into 4, 1 big one and 3 small ones. And so I step back and I look at something like that, and I don't know what we're looking at, but Congress is interested in that. And that to me is the interesting part about this, where Congress is looking for answers to these objects that are being detected in our sky by our own military. Well, and the military doesn't have an explanation for it. That's what I find
a friend of mine, a colleague of mine, David Sprogel, was the head of the commission, the scientific commission that examined all of the evidence, including the anomalous evidence of things.
You're talking about for Arrow?
whatever the scientific commission from the National Academy of Sciences that was set up. I think it was the National Academy of Sciences, it might have been the Air Force. But David Spergel, who was at Princeton now at head of a foundation, they examined all of this and said, once again, no evidence. And so when some congressman presents a video, that's nice. And it's great that Congress is investigating things. I think they probably have better things to do with their time, in my opinion. A lot better things to do with their time. A lot of other problems that are far more pressing that they could actually spend time trying to solve. But fine. But, once again, it's nice that congressmen show these videos, but videos I can show you a million videos on X every day of things that are more exotic and also wrong. And so there are lots of things that are unexplained. There are lots of things that are not easily explained. But once again, that doesn't mean, first of all, that we don't understand any of them at all, or that we can't understand any of them all. And it also doesn't mean the first postulate you should make is the least likely postulate. Once again, it seems to people that when you see something that's so strange you can't explain it, it must be due to aliens. But that's a supposition that's been invented by Hollywood or something like it. As I told you, 200 years ago, the answer was it was fairies. 200 years before that, it was demons. You pick your, and so it's great that, if Congress investigated all the things we see that we don't understand, they could spend all their time doing that. Forget just UFOs and anything. And it's great. And we call that science. And science tries to investigate things we don't understand and tries to explain them. And that's what we spend our time trying to do. And by the way, we try and prove our colleagues wrong. What the other thing people don't understand about science is it's not as if we all get a PhD and we do this private pledge with black hats on saying we all agree to this reality and none of us are going to allow anything else. Instead, we actually try and prove each other wrong, because only then do you get some kind of, if you're right, some kind of notoriety and fame or whatever else scientists seek. So some congressman presenting a video does nothing for me. I'm sorry.
Well, what I find so interesting about all of this is suddenly, and I don't have an explanation for this, but suddenly the media, Congress, Capitol Hill, the Pentagon, where this subject was always taboo and funny and tinfoil hats and everything else, that suddenly, since 2017, it's an okay subject to talk about, and it's okay now, and the public is not. The Vatican didn't collapse, right? Wall Street didn't collapse. All of these predictions about society is okay. And suddenly it's a subject.
About that, anyway, yeah.
Yeah, right. I overstepped. But suddenly it's a subject that's okay to talk about without being laughed at, not having the X-Files music.
Yeah, and and it's hard to know the sociological reasons for that, except I think you've got a few things. You've got social media, which is now extremely powerful, and Congress people know that social media has a big audience. And so social media tends to be, I hate to say it, dominated by fringe groups and who like things like this. And so it's not so surprising that Congress follows its nose to please a set of people. So maybe it's not surprising it didn't happen until the rise of social media. And there are lots and there's new technology, so there's lots of ways of people to demonstrate, to present these weird videos and other things. So yeah, it's kind of interesting that it's an okay subject, but having said that, it's not very surprising is Congress says, and we're gonna give this group of scientists access to all the data, including top secret data, right? And we're gonna let them look at this, and they're going to come to some conclusions. And the result was not too interesting. But then that doesn't stop any of it. So, of course,
isn't it? You're right though. What was fringe is now normal.
exactly.
How do we get here? I like the old version when it was just us in our little freaky world.
Yeah, no, it was a lot more fun. One of my favorite faculty members and most brilliant guys I knew when I was at Harvard, who's now dead, Sidney Coleman, was smarter than any of my other colleagues who all won the Nobel Prize at Harvard. But he used to crave the old days when science fiction was kind of sleazy and scuzzy, and he'd get these old science fiction magazines, which he loved, and he'd go to these science fiction conventions, which were fringe and weird people. He loved that kind of stuff. And I think, yeah, maybe we harken back to the old days when science fiction was a little less mainstream. Let me put it that way.
Let me ask you one thing before we wrap up tonight. I have the opportunity to go into this zone. Is the intellectual world as competitive as anything else, sports or entertainment? Is it competitive? Is it a world of ego where you guys are trying to outsmart each other?
Of course, it's more well, it's at least as competitive. Yeah, it's one of the most competitive. And you know why? There's so much chaff and so little wheat. The low-hanging fruit has been taken, and it's hard. And it's really hard to make an impact. And there are a lot of people doing it more than ever. It's incredibly competitive, and as it should be. You know why? Because it's a privilege to be able to. It's been a privilege for me for most of my life to be supported, to be able to do whatever the hell I want and ask whatever hell questions I want. It's not something I think society can afford to allow most people to do, and it's a privilege I feel fortunate to have had. And I like to think I got it because I was able to do it well. And I think it should be rare and it should be competitive, so that only the people that do it well succeed at it, because society can't afford for everyone to be doing it. Not now. Maybe when AI is dominates and all of us have a lot of spare time, all of us can do it. But anyway, so I think it is competitive, and it should be competitive, and people shouldn't expect that they should have a free ride in that regard, and not everyone should be able to do it, and we should. And that's part of the content of, I can't help but show my recent book, The War on Science. One of the reasons why I think merit is the important factor that should determine who succeeds in academia, and not other things. And we can't afford. Science is too important. It's the way it would allow us to address the challenges of the 21st century and ensure the health and welfare and economic well-being of our society. It's too important to not have science proceed on the basis of merit, and because we all depend on that.
What I enjoy, but at the same time I kind of abhor these thoughts, is that I'm not going to name any names. I don't do that on this program, but there are some big brains out there that have become rock stars. And I'm not sure if they're whiteboarding or doing any algorithmic research at all, and instead focus on clicks and their audience, and they speak to that and have ignored actual research. And that's where that's what scares me, where too many. Now the audience has grown so big where it's become a money thing for some of these rock stars. And that's what scares me, because people focus on it being gospel and the truth to them.
Yeah, well, I mean, there's a big attraction to that. And I think it happens, but I suspect it's happened a lot of times. Some people, used to say that about Carl Sagan, but I think he was a good scientist, and he got a lot of flack for reaching out to the public, and that was unfortunate. But you're right. I mean, the lure of money and the lure of attention is great, and so you should be suspicious of everyone, including me. And heaven forbid. And I think when the internet, when I've been around the internet longer than most people, because it began with physics and the physics community. And I used to think it was great. It was going to allow people access to more information than they would ever possibly have, which is true. But it also now allows people access to more misinformation. So the important way to learn in the modern world is to learn how to tell the wheat from the chaff, and to be skeptical of what you read and test it and see which sources seem more credible on the basis of then finding out which ones agree with the evidence of reality more often. And even then they can be wrong. And so we have to learn, not facts aren't important because you can get them. You have to learn how to tell the facts from the non-facts, and that's a different way of thinking. And science, for better or worse, is the way to do that.
I love woo-woo. I love to let my imagination go, but what keeps me grounded is science, right? So I'll go and I'll look into stuff, and science grounds me again. But science is starting to get more woo than the woo-woo.
Well, sometimes it is. Some of it is.
I love it. I love that part of it where the crazy stuff that I used to imagine. Let's go to your Star Trek books, right? That science is being pushed to look into things because of these ideas and some of the woo that's out there. And I love that part of it. I truly do. Where as crazy as my thoughts can be sometimes, and I go to science to help ground me, and then suddenly I've got quantum computers and quantum mechanics and qubits and 11 dimensions and the multiverse and multi-worlds and these crazy, where our woo-woo community is not that nuts. Science is out there really pushing it.
I find the craziness of science to be so much more imaginative than the craziest of woo-woo. That's what makes it interesting. And that's why I find science much more fascinating than science fiction. Because once again, the imagination of nature is far greater than the imagination of human beings. And so the universe will keep surprising us. And I love that. And that's what has kept me being a scientist for as long as I have been. And I hope it'll continue to keep surprising me. I see no evidence of the contrary. And I love being surprised. And just like I love being wrong. The one or two times in my life that's happened.
So dark energy, the expansion of the universe, I figured it out.
Oh, good. I was going to say we have 1 or 2 minutes left. I'm glad you did.
Yeah, I figured it out.
Oh,
okay,
good.
This is what I think it is. Are you ready?
Absolutely.
I think it is information and consciousness. That's what it is. I think that's what dark energy is.
Great. It doesn't behave like information or consciousness.
That's right. And nobody knows, but
it doesn't have the gravitational properties of information or consciousness. So I would argue that there's strong evidence it can't be either, because both those things are gravitationally attractive and not repulsive. And
so the next time you're on the show, we'll discuss it deeper.
We'll discuss why that idea is wrong. That's my job. Okay.
Lawrence, thank you for everything, man, and your contributions. And what a great conversation tonight. And I really appreciate it. Your books have moved me and motivated me and will continue to do so. So just thank you on behalf of our community. Thank you for everything that you have brought to us.
It's wonderful. I really appreciate that. And it's been, as I say, it's been fun. And keep up the good work yourself.
I appreciate it. Lawrence M Krauss, everybody. His links are below. Thank you so much, sir. Have a great night.
You take care. Best.
Thank you so much. What a perfect conversation. That right there is a perfect conversation. So much fun. And what a great week on the show. And having Lawrence on the show with us tonight really meant a lot to me. And it's about me learning. And if I learn, you learn right along with me. All right. I do want to remind everybody what is going on tomorrow night. Let me see what is going on tomorrow night. Oh, yeah. Tomorrow night, Lynn Buchanan is on with us. Part of the Stargate program with the United States military and remote viewing. And yes, he is one of the OG remote viewers for the United States Army. So tomorrow night, Lynn Buchanan joins us. Thank you, Lawrence M. Krauss. What a great conversation. I am your host, Jimmy Church. This is Fade to Black. And you know what I've got? That's nothing but Go Backley Tappy. Fade to Black is produced by Hilton J. Palm, Renee Newman, and Michelle Freed. Special thanks to Bill, John, Dex, Jessica, Dennis, and Kevin. Webmaster is Drew the Geek. Music by Doug Aldrich. Intro, Space Boy. Fade to Black is produced by KJCR for the Game Changer Network. This broadcast is owned and copyrighted 2024 by Fade to Black and the Game Changer Network, Inc. It cannot be rebroadcast, downloaded, copied, or used anywhere in the known universe without written permission from Fade to Black or the Game Changer Network. I'm your host, Jimmy Church. Go back, Lee Tappy.